1.5b. Remember we just did f prime of 1 equals 2 times 1 is equals 2 with the equation f of x equals x squared. Now we're going to do an easier way. We have a theorem. It's called the power rule. Okay, and it states if f of x equals x to the nth power, f prime of x equals n times to the power of n minus 1. So let's do an example of this. Since we had discussed f of x equals x squared, we're going now to do f prime of x using the power rule. And it says to bring the exponent in front. Here we have the exponent. And then we take that exponent and minus 1. So that equals 2x to the 1, which is 2x. And that's what we got earlier. So let's do another one. Before we do that though, let's apply, we put a 1 in there, let's apply a 3. If we put a 3 in there, we have 2 times 3, which equals 6. Now again, what does this 6 represent? That's right, it's the slope of the tangent line at x equal 3. Okay, so now let's do another one using the power rule. So let's try f of x equals x to the 5th. F prime of x equals 5, x to the minus 1 from 5, 4. See how easy that is? Let's do another one. F of x equals x cubed. F prime of x equals, we're going to bring the 3 down, 3x, and then we take away 1 from 3, which is 2. Okay, let's try a different one. How about f of x equals 6x cubed? F of x equals 6x cubed. Well, f prime of x, we're going to keep that 6 there, but now we're going to times it by what we bring down. We bring down the 3, x to the 3 minus 1, which is 2. 6 times 3 is 18, so our answer is 18x squared. Okay, let's do some more of those using the power rule. Okay, now remember, we know f of x equals y. So sometimes you'll see it stated this way, y equals x to the 4th. So how we handle this is to do the derivative, we call it y prime. Y prime equals, we bring the 4 down, and then we minus 1. Okay? Now what if we had y equals the square root, not the square root, sorry, the 5th root of x? Well, before we can even take this derivative, let's change the root to a fractional exponent. It's x to 1/5. Remember, the root goes in the denominator. So if we take y prime, we're still going to bring 1/5 down, x to the 1/5 minus 1. Okay, well, how do we do this 1/5 minus 1? It's the same thing as y prime equals 1/5 x2, and this is a little trick I use and I teach when I teach algebra. To minus our 1, we just use that denominator and go 5 over 5, because 5 over 5 is 1. And now we can subtract because we have the same denominator. Okay, so we're going to say y prime equals 1/5 x to negative 4/5. All right, now in this class, generally when we see a negative exponent, we're going to go ahead and put it in the denominator. So we have 1/5 and we bring this down and change it to a positive exponent. Okay, we're going to take it one step further. If we begin with a radical, we're going to end with a radical. Right now we don't have a radical. Because I'm out of room here, I'm going to bring this over here to make it into a radical number. So we have 1 over 5. That remains the same. Now we change this to a radical number. Remember, the denominator is the root. So that's 5 as the root. And we leave the 4 inside. And that would be our answer. Okay, now I'm going to have you do the power rule. Normally, when you're in class, I have you do this in groups. What I'm going to have you do is do it on your own, and then I'll come back and we'll talk about the answers. Okay, so I'm going to put a little G here. That means group. That means you're going to work on your own right now. So find the derivative for f of x equals x to the 7th. I'm going to give you 4 problems. Y equals x to the 5th. Y equals 4x squared. And f of x equals x to the negative 2. All right, so go ahead and work on those. Okay, let's see how you did. On the first one, f prime of x, we bring the 7 down, and then we take away from 1 from 7, 7x squared. See how easy that is? Okay, the next one, f prime of x equals, we're going to bring this 5 down, take away 1 from the 5, so we have 5x4. Okay, this next one. Ooh, here I wrote y and wrote f prime of x, which is okay, but generally, since this is a y, we say y prime. Okay, next one, we have a y here, so I'm going to call it y prime as the derivative. We bring the 2 down and multiply it by the 4, which becomes 8. 2 times 4 is 8. And then we take away 1 from the 2, which gives us 1. So the answer is 8x. Okay, last one. F of x is x to the negative 2. So f prime of x equals, we bring down the negative 2, x to the negative 2 minus 1, because we're always taking away 1. So that is negative 2, x to the negative 3. We started out with a negative, so it's okay to have a negative exponent. If you wanted to go further, that would be fine with me. It would be negative 2 over x cubed. Okay, I have one more thing to show you, and we are done with this lecture as well. Very good, by the way. I can tell you did well. Okay, so more notation we're going to be looking at. More notation. So far we've seen f of x and then f prime of x, and we saw y and y prime. We have another way, and that is f prime of x equals dy dx. F prime of x equals dy dx. That's just how we say it. And how we would actually formally say this is the derivative of y with respect to x. I'll write that down. The derivative of y. The derivative of y with respect to x. That's how we would say that in longhand. We just say dy dx. Okay, so let's go back to if y equals x squared. Then we would write it f prime of x equals d dx x squared. D dx x squared. Okay, so here's an example. If we were asked to do d dx, I'm going to put this over here, 7x to the fourth, just think of it as a derivative. That's all this means. We'd bring that 4 down, so we have 7 times 4. Keep the x, subtract 1 from 4 is 3, and our answer would be 28x cubed.